This is the review for the Unit 2 test that we did in class. So we started out with 2 pages of definitions and things that we need to know. So just to recap the entire unit. This is all from Chapter 3, 3A, 3B, 3D, and 3E, I think. But 3A was dealing all with about percents and percent problems. So the first thing that we talked about was how to go back and forth between percents, decimals, and fractions. To go from a fraction to a decimal, you simply divide. Now, going from percent to decimal and decimal to percent, we use the Dr. Pepper rule. If you're going from percent to decimal, that means you move left 2 places. If you're going from decimal to percent, that means you go right 2 places. Our next thing here is the percent equation, and having a basic understanding of this is really what will indicate success in this. You're always going to do a percent of the reference value is the compared value. The compared value and the percent are talking about the same thing, and it's a percent of a reference value is a compared value. So these are the compared value as a number and as a percent. You are going to need to know this equation and know how to use it. Then we talked about percent increase and decrease, or percent more than. If the non-member fee is 20% more than the member fee, or if the something increased by 10%, or it increased by $3, or whatever the situation is. Your reference value is what you're starting with. What are you increasing? So, and that's going to be 100% plus the percent of the increase. So the 100%, say this is a 20% increase. It would be 100% plus 20%, and that would be the percent of. And that percent is going to deal with the compared value. If you're dealing with a percent decrease, you're going to start off with your reference value is 100%, and then you're taking away the percent of decrease. So if you've got an item that is $800 and it is on sale 10% off, the reference value is the original cost minus the 10%, so it would be 90% of, and that is the compared value. Percent of versus times. I didn't really know how to title this, but times is just percent of as a decimal. 1.2 times something is 120% of, for example. Absolute change, you're going to need to know this, and this is just your compared value minus your reference value. It is a number. When you do your subtraction, compared minus reference, if that number is positive, that means it's gone up. If it is negative, that means it has gone down. When talking about change, we also have relative change, and this is as a percent. So it's just the compared value minus the reference value over the reference value, which is the absolute change divided by the reference value, and it is given as a percent. Finally, we have our abuses of percent, which are dealing with shifting reference values. If you have a percent off and then another percent off, you have to change your reference value. If you're averaging averages, that is an abuse of percent. You can't. If you have, one of the examples we used in class was your grade. If it's split up 80-20, then if your homework grade, which is 20%, is 75, and your test grade, which is 80%, is 65, that doesn't mean you're getting a 70. It actually works out to about a 68. And then the third one is really obvious. It's a discount of more than 100%. If you go in to buy something and they say that it's 150% off, that means you buy them and they have to give you money. So that's everything in 3A. Then we went to 3B. Now we talked a lot about scientific notation. Mostly we just need to know how to go back and forth between scientific notation and number, or a number and scientific notation. Scientific notation, of course, is a times 10 to the n. This number has to be between 1 and 10. And this number has to be an integer, which means 1, 2, 3, 4, 5, no fractions, no decimals. If your exponent is positive, then it's a big number. If it's negative, it's a small number. And just know how to use your calculator. Okay, if there are any questions in these. Because the main reason that we're dealing with scientific notation is to do energy conversions. Okay, but this is where knowing how to use your scientific notation really comes into play. When you're dealing with unit conversions, okay, it usually will say how many so-and-so. That is where you're ending up with. That is the units you want to end up with. Now, those units are always going to be given to you on the table as an equivalence for whatever your units are and the number of joules. If it is a candy bar, the number of joules. If it is an hour of running, it is the number of joules. If it is energy for 1 year, it would be given in joules. Okay. Well, then what do you want to get and turn into that? So you're going to be given a starting amount. And it is not going to be in joules, so it is not an energy. It is just going to be, if it's energy per year, then the units would be year, or per day, or per hour, or whatever it is. Okay. And then you're going to do at least 2 conversions. Okay. The example that we're going to do in class involves 3. But you're going to take that given unit over 1, then you're going to convert that unit into joules. Then you're going to multiply that times your ending unit over the joules so that your given units cross out and your joules cross out, and then you end up with what you want to know. Now, this is one where it's really going to be important that you know how to use your calculator. If you are, because you're going to be dealing with something times 10 to the something in joules, something times 10 to the something, your scientific notation. Remember that you have to put the numerator in parentheses, you have to put the denominator in parentheses. Okay. All right. So then we went to the consumer price index, which was, we always have a lot of good discussion in there, and what's really going on, what does it mean for my personal finance and that sort of thing. But if you want to compare the CPIs, what you're doing is you are just taking the compared year is equal to X times the CPI in the reference year. So identifying the compared and reference year are really important. Normally, the compared year is newer than the reference year, and this is going to be larger than this one. But anyway, it will tell you what your percent is. Okay. All right, so you're going to need to know this formula, the cost due to inflation. If a car sold for $20,000 in 2000, what would be its equivalent cost today due to inflation? Okay, so you're going to look at your price in your compared year. That's what we're looking for. So that's going to equal the price in your reference year times the CPI of the compared year divided by the CPI of the reference year. Okay, I have never found a good way to abbreviate these, but whatever you do with them is absolutely fine. Okay, and then of course, since your price, you're going to turn it into a fraction by just putting it over 1. Okay, now the rate of inflation, this is really easy if you know your relative change formula, because you're just going to compare the CPIs. For the CPI from the compared year, the CPI from the reference year divided by the CPI from the reference year. Okay, so that was it, but you've got to know these formulas. And we talked about brain dump. That would be a good thing for you to brain dump when you get the test. Okay. Then our last topic was about false positives and false negatives. And of course, there's so much in the news about COVID testing that this is something that you've probably heard more than you want to about it. Okay. This goes to whatever the disease is or whatever the condition is, whether they have it or they don't have it, and whether they tested that they had it or tested that they didn't have it. Okay. The key to success, in my opinion, for this is labeling each of these blanks. What is a true positive, a false negative, and a true negative? And knowing which one of these are accurate results and which ones are inaccurate. These that are true along this diagonal are accurate. The inaccurate ones are the ones that are false. And then, of course, you've got your total participants. Okay, but in my mind, it is helpful a little bit to go through and label all these things. Okay, well, enough talk. Let's go ahead and start working some problems. So that is your summary for this. You will want this summary. You will also want your tables so that you can use those. And we'll start on some practice problems. Okie dokie. So the first problem on here says that the cost of a gallon of gasoline was $1.88 a year ago. The price has increased 41%. What is the cost of a gallon of gasoline today? Okay. Well, the first thing we want to do when we're looking at a problem like this is figure out really what are we doing and how do we get there? Well, I know that just reading this, if I do a quick translation, I know that the gas 1 year ago is my reference value. Why? Because they're saying that this is the price increase here is based on the reference value. I also know that my equation is some percent of the reference value is equal to the compared value. So I know that these two items are the same. These are the same as a number and as a percent. Okay. Well, and since it's a price increase, I know this is a percent increase. My reference value is 100%, and that is the gas 1 year ago, plus the percent increase, which is 41%, so that's almost half. And that's going to equal the compared value. So 100% plus 41% tells me that my percent is 141%. I know the reference value is $1.88. The cost today is what we want to know, so that's my variable. Okay. I have to turn this into a decimal. So that becomes 1.41 times 1.88 is equal to X, which tells me that the price today is $2.65. Okay, last time I went to Kirby Lane, the bill including a 30% tip was $106.60. What was the cost of the food, including the tax? Okay, now this is the one that is the hardest to do because your first inclination is, well, I'll just take 30% of 106.60. You're not, because then you're giving a tip on the tip. Okay. Okay. So you know that this 106.60 is the total, and it equals the food plus the tip. To find the tip, you have to know the food. So this has to be our reference value. So when I set up my equation, it's going to be some percent of the food equals the food plus the tip. Okay, and I say these things a little bit differently every time I do it. Okay, so we know the food is our reference value, which is 100%, plus the tip, which is 30%, and that is our compared value. So 100% plus 30% is 130% of the food, which we don't know, is the total bill. We know that one. Change that to a decimal, so 1.30 times x is equal to 106.60, which means that x is $82. Okay. All right, now we're going to be comparing values to each other. So the cost of a Tesla is $90,000 and the cost of the Honda Fit is 75% less than the cost of a Tesla. Okay. All right, well, in this starting out, our reference value this is going to be our reference value, and this is going to be our compared value because they're taking 75% less than this. Okay, so 75% less than means that it is 100%, which is minus 75%, which is 25%. If it's 75% less than, it is 25% of. And to find out how many times, we're going to take the percent of and turn it into a decimal, which is 0.25 times the cost of the Tesla. Now, this is another way of saying this. Okay, I started out with my Tesla. So my reference value is my Tesla, which is 100%. And then I am taking away from it 75%. So 100% minus 75% is 25%. So 25% of the Tesla is the Honda. So 0.25 times 90,000 is the Honda. So if I do my multiplication here, that gives me 22.5. Now when we do this next one, if you look at it, the cost of the Tesla is what percent more than the cost of the Honda? That means that my Honda is now the reference value and we are comparing the Tesla to that. So to find that, we're just going to use the relative change formula. Which of course means the compared value minus the reference value divided by the reference value, which is 90,000 minus 22,500 divided by 22,500, and when I do that I get 3. But I have to turn that into a percent. So if I turn that into a percent, I move this 2 places, so that is 300% more than. Okay. All right, let's see. On vacation, whoops, you can't see that. On vacation, you purchased a painting from a local artist for $2,000. Since the purchase, the artist has gained national attention and the painting you purchased is now worth $5,000. Find the absolute and relative change of the painting. Okay. Well, what we are comparing the current value to what we bought it for, which is our reference value. So our absolute change is just our compared value minus our reference value, which is 5,000 minus 2,000, which is $3,000. So the absolute change in value is $3,000. So our relative change now is our compared value minus our reference value divided by our reference value, which is 5,000 minus 2,000 divided by 2,000. 3,000 divided by 2,000 gives us 1.5, but of course we have to turn this into a percent, which is 150%. Okay, all right. The original price of a generator is $800. It is on sale for 20% off the original price, and you have a coupon for an additional 15% off the sales price. Okay, you don't just get to add those together and say that they are 35% off, because this is a shifting reference value. And it's a two-step process. Okay. So step one is going to be the 20% off the original price. Okay, so the original price and the 20% off the original price, this is the step one. Okay. So again, our reference value is the original price, and we're going to take off 20% of that. So 100% minus 20% is 80% of the original price is the sale price. Okay. If it's 20% off, then I still have to pay 80% of it. So this becomes 0.80 times $800 is equal to X. So X is $640. This is the new reference value for step two. So in step two, I'm going to have 15% off the original price. Okay, so again, my reference value, which is the sale price, and then I'm going to take off 15% of that. So 100% minus 15% gives me 85% of the sale price is the final cost. So this is 0.85 times 640, is X, so our final cost is $544. Okay, so what is the actual percent off? Okay, well, we can figure that one. All we have to do is to find the percent. Of course, that's just a fraction. So it is just going to be the final price divided by the original price, which equals 544 over 800. That turns out to be 0.68 or 68%. And this is the percent of, not the percent off. Percent of. Okie dokie, I'm going to switch videos and we'll be back to finish.